Do you know how the Liskov substitution principle works? Imagine that you need to create a program to manage birds in a zoo. You need to manage hawks and ostriches. As some properties will be repeated, you decide to create a superclass and two subclasses as representations. And it turns out that the zoo uses birds to deliver letters on a nearby island. As the falcon is able to fly, it can deliver the letter. But the same doesn't happen with the ostrich. The problem is here. As the ostrich is a subclass of birds, it automatically inherits the fly method even though it can't fly. The Liskov substitution principle states that a superclass should be able to be replaced by one of its subclasses, but if we replace the class birds that has the fly method with ostrich, we are breaking the principle because the method will not exhibit the correct behavior. But how to solve the problem? We can create two more superclasses, birds that fly and birds that don't fly. Now we won't inherit something that won't be used. Now the superclass bird is no longer applicable for the send letter method since it does not have the fly method. The new superclass birds that fly is going to occupy that role. Note now that if we substitute any one of the subclasses of birds that fly, we will have the expected behavior and side effects. So now we will be adhering to the Liskov substitution principle. It's not that difficult, but notice one more thing. Just because hawk implements the fly method doesn't mean we're already following the Liskov substitution principle. Consider if the programmer overrides the fly method for the hawk to start doing somersaults. This will cause a problem when delivering letters, as it was not an expected behavior. So, to ensure that your project is following the Liskov substitution principle, remember, objects in a program should be replaceable with instances of their subtypes, without altering the functionality of the program.